So today we've been asked to solve x to the log x power equals 1000x squared. And what I'm going to do today is I'm going to exploit a property of logarithms. And what we're going to do is we're going to take the log of both sides, because I don't like having this logarithm as part of an exponent. If I take the log of both sides, this exponent can come out as a multiplier. So I'm going to rewrite these and say log of x to the log x power and log of 1000x squared. Okay? Now, on this left-hand side, this exponent can come out as a multiplier, so I get log x times log x. And over here, I can use my product to sum rule, and I've got 1000 times x squared, so I can rewrite this as a sum, log of 1000 plus log of x squared. Okay? And of course, log x times log x, what's that going to give me? That's going to give me log x squared. And then here, log of 1000 is the same as log of 10 to the third, log of x squared. And I'm going to use that same property. I've got an exponent here, I've got an exponent here. Those can both come out as multipliers. So I get log x squared equals 3 log 10 plus 2 log x. Now, what is the base of this logarithm? It's a base 10 log. Log 10 of 10 is just 1. So what does this become? Just 3. And then here, of course, you've got 2 times log of x. Now, if I look at this, I've got log x squared, log x to the first power, and then a constant. And I have a quadratic. So I'm going to write this in standard form as a quadratic. Log x squared minus 2 log x minus 3 equals 0. And I look at that and it looks very complicated to me, but it is a quadratic. And so what I'm going to do is I'm going to use a little math trick called substitution. You've got log of x, you've got log of x, and you've got a constant. And I'm going to say everywhere you have log x, put an a. And so this is equivalent to a squared minus 2a minus 3 equals 0. Factor this expression and you get a minus 3 times a plus 1 equals 0. And then of course, if you solve these two factors, you would get two answers. You would get a equals 3 and a equals negative 1. Now take this little substitution equation that I just did, and everywhere you have a, plug back in log of x. So what do we have? We have log of x equals 3, and we have log of x equals negative 1. So we took a and put log of x. So log of x equals 3, log of x equals negative 1. Solve these two equations. I'll start with log of x equals 3. The base is 10, so I take the anti-log of both sides, and I get x equals 10 to the third, which is x equals 1000. And then over here, I take the anti-log of both sides, since it's log base 10, and I get x equals 10 to the negative 1 power, which is x equals 1/10 or 0.1. Okay? And the last thing you could do is take these two answers and plug them back into your original equation and make sure that they both give you equality for both sides. Now, the way I like to do that is real simple, especially when we have a logarithm, is to use my calculator. So I'm going to take this side, and the first thing I'm going to do is I'm going to try 1000. So I'm going to say log of 1000 equals 3, and then x raised to the third power. So 1000 raised to the third power, and I get this humongous number looks like 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Okay, 9 zeros. That should be a billion. Okay, now look at this side. What do we have? We have 1,000 times 1,000 squared. What does that give me? Same answer. So the left-hand side and the right-hand side are equal. So I know this answer is correct. Same thing over here. We're going to use 1/10 or 0.1. Okay. I take the log of 0.1, and that's -1. So I say 1/10 raised to the -1 power. Okay. So 1/10 raised to the -1 power. And on the left-hand side, I get 10. Now on the right-hand side, I've got 1,000 times 0.1 squared. And what do I get? 10. So this second answer also works. These answers are correct. If you have any questions, please come see me.